Okay guys, so we're going to be going back and doing some stuff on trigonometry. You've been looking at some of the trig graphs for me for your homework, and now we're going to be thinking about how we do some transformations to trig graphs. But before we do that, I wanted to test you on what you remember from year 12. So let's have a look at some of these questions that I've got here. What I want you to do is to try and describe the following transformations to graphs just from the original graph f of x. I want you to try and say what these different transformations here would do. So if you pause the video and then have a think about how you would do this, I'm going to start going through these after you've had a chance to answer them yourself, okay? Okay, so this first one here where we're just adding on 2 to the function, this is just going to be a translation, and it's going to move 2 up. So remember what translation 2 up would look like. It would be 0, 2. So the whole graph just moves 2 spaces upwards. This one, similarly, will be a translation, and this time it's not going to be going 2 up, it is going to be going 2 down. This one is a stretch of the y coordinates. So it is a stretch, and it's a stretch in the up and down direction, and it's a scale factor, so I'm just going to write SF, it's a scale factor of multiplying it by 2. So however high, and the y coordinates are all going to be doubled, so in other words it's going to get twice as high and twice as stretched down low. This one is also going to be a stretch, and it's also in the up and down direction because it's outside the function, and that's this time the scale factor is a half, so all of the y coordinates are being halved, so it's actually going to end up being sort of more squat. It's going to be closer to the x-axis because all the y coordinates are being halved. Now this one is a reflection, and this one is a reflection in the x-axis. Whoops, in the x-axis. So in other words, everything that was up here is going to go down here, and everything down here is going to go up here. That's because the y coordinates are being multiplied by -1. So if your y coordinate was 3, it's going to become -3, and if it was -2, it's going to become 2. So that's why it's a reflection in the x-axis. So these ones here are all things doing up and down. This one kind of flips up and down, this one stretches, and this one moves up and down. These ones are all stuff that go left and right, and left and right, things in the x direction, kind of does a little bit of what you might not expect. So this one is going to be a translation, but because it's x plus 2, it doesn't actually move 2 to the right, it actually does the opposite. It moves 2 to the left for this one. And this one is a translation 2, and for this translation, it moves 2 to the right. So it's going to the right this time, and that's because it's subtracting 2, so it actually does the opposite from what you think. It doesn't move to the left, it actually moves to the right. Now this one is a stretch, but this time we're talking about it in the left and right direction, and when it's inside the brackets, like here, it did the opposite to what you might expect. It also does the opposite for what you might expect here. So 2x, it won't be a scale factor of 2 in that direction, it will actually be a scale factor of 1 over 2. It will be a scale factor of the reciprocal of this. So this one's actually a compression, like inwards, okay? Then this time, it's inside the brackets, that half, so it's going to be a stretch in the left and right direction, and the scale factor is going to be the reciprocal of a half, which is 2. So this means it's now going to be getting 2 times longer and stretched out in that direction. And then last of all, this one does a reflection, and instead of this one doing a reflection in the x-axis, it's going to be a reflection in the y-axis. So if I just draw a quick sketch of what I mean by that and how it still relates to everything here being kind of left and right, all of the x coordinates that were over here are now going to go over here, and vice versa. Those ones that are over here are going to go over here. So the whole graph kind of flips over the y-axis that you have. That's kind of like the mirror line. And that's because you're taking any of the x values. Let's say you were taking the x value 3. You're then, instead of putting in 3, you're actually putting in -3. So you end up with what you get over there. Okay? So you need to make sure that you know all of these ones, because if you can't do these ones, you're going to find the trig ones pretty tricky. Okay? So let's have a look now at trying to transform trig graphs. Now I've put here the sine graph just to try and make our life a little bit easier. And in fact, I'm actually probably going to draw out the sine graph again here. In fact, I'm going to treat myself to some proper axes. So why don't I just quickly go to my shapes here, and let's put in some tools. Now I want it just to be drawn between 0 and 360. So I'll start off with my vertical axis, and I will have my horizontal axis along here. Now, the 4 is outside the front, so our normal function that we're talking about, f of x, is sine of x. So the one that we're trying to sketch is 4f of x, 4 sine x. So we know that this is going to be a stretch in the up and down direction, a scale factor of 4. So it means all of these bits are going to get 4 multiplied by 4. So instead of it starting at, instead of it going up to 1 here, it's going to go all the way up to 4. So I'm going to draw out that bit. It's going to go up to 4. The bit when it's at 0, well, if you multiply 0 by 4, you get 0. This is going to stay at 0, because if you multiply 0 by 4, you get 0. And this one goes down to -1, so it's going to go down all the way to -4. So actually what this one looks like is just going to be like a sine curve like this, between 0 and 360, but just to make it clear that we know that we've done the correct sketch that we have here, I'm still going to have to say that this is 0, this middle bit, if you remember, should be 180, this is 360, and really the only feature that's different is that instead of the peak being at 1, the peak here would be at 4, and instead of this trough being at -1, the trough will now be at -4 instead. If you wanted to, you could say that this is 90 degrees, and equally you could say that this here is 270 degrees. If I were to draw the original sine graph, the sine graph would look like this. It would be the same underneath, like this, but it would only be going to 1 and -1. So this multiplying it by 4 has stretched it all the way up to 4 and all the way down to -4. So let's have a look. Actually, I think I've got it here. Here is my sine x. I'm now going to type in 4 sine x as well. And the bit that we wanted to draw was between 0 and 360. So there's the answer, which is the blue one. The original graph that we know how to draw is the red one, which is sine of x. So let's go back and see if we can do another question now. Okay, so this time we're being asked to sketch y equals cos x plus 45. Okay, so our original function that we already know about is cos. That's the one that we know how to draw so far. So I'm going to write out f of x is equal to cos of x. Now you need to say to yourself, how do you go from this to this? Well, if it was f of x plus 45, you would have cos of x plus 45. But this is not the same as this, okay? This one is not correct. So I'm not going to get rid of it yet. I'm going to show you why it's not correct. The one that we should be saying is it's f of x plus 45 with the plus 45 inside the brackets. Because this would be inputting, instead of inputting x, we're actually inputting x plus 45. So it's a bit like BIDMAS. In this one, you're doing the cosine of x, and then you're adding 45. In this one, you're adding 45 to x, and then doing the cosine function to it. So it is not this version that we have up here. It is indeed this version that we have. And we know that f of x plus 45 is a translation, and because it's inside the brackets, we know it's in the x direction, so it's going to be a translation. It looks like it's going to be an add 45, but we know it's the opposite of that. It's going to be 45, 0. So really this is a translation of 45 to go to the left, okay? So here's the cosine graph that I've got of a bit of a helping hand. It's just useful to think about where the key points actually are. So it crosses at 90, which means in our new one, it's going to cross at 45. The bottom bit is at 180. So in our new one, the bottom bit is going to be at 180 minus 45, which is 135. And it crosses at 270 here. So our one is going to cross at 45 back from that, which is 225. The peak here is at 360, so that is going to be going at the peak 45 back, which is actually going to be at 315. So what I've done is I've just subtracted 45 from all of these values, and I'm actually going to just put those on my diagram. 90 take away 45, 45. 180 take away 45 is 135. 270 take away 45 is 225, and 360 take away 45 is 315. So we're going to get a sense of what's going to happen to this graph. The whole thing is kind of shifting along, so it looks like we're going to get this kind of the cosine graph has like completely shifted to the left. So I am going to add in some lines because I want this just to be drawn between 0 and 360. Now it might be helpful to draw a little bit further than this because we're used to drawing the cosine shape normally. So I might actually pretend it's going to start at minus 45 here because I know that's where there would be a peak. Then I've got my 45, 90, 135, 180, 225, 270, and 315, and 360. So actually what I know is going to happen, it's going to go from here, and then I said it's going to cross at 45, so it's going to go from here to here. The peak, sorry, the lower bit is going to be at 135, so that's 45, that's 90, that's 135 that's over here. Then we can say it crosses again, that's 180, so this will be 225 here, and then it reaches the peak at 315 over here. So it looks like the graph is actually going to do this, okay? It's going to go down like this. Oh my gosh, this is terrible. Let's see if I can draw this a little bit better. So it's going to start here, and it's going to come, right, definitely not my best. Okay, cosine graph, here we go. I promise you I'm better at this on paper. That gets up to 315. Now if you think about what would happen when it gets to 360, it comes down a bit. Now we actually wouldn't want this bit of the graph because I only wanted it between 0 and 360. So I'm just going to put in these values where it should have crossed. That was supposed to be 45. This is going to be 135, where that bottom peak is here. We said that it was going to cross at 225 here, and we said that this value here is 315. Oh, I wish I just had my normal whiteboard rather than this one. And then this end value is 360. Really the key things that they're looking for is that this bottom peak is going to be at 135 because it's shifted 45 to the left, and this bit here is meant to be 45. It doesn't start at the top, it actually starts up here and kind of is already on the downhill at this stage. So the whole thing is kind of shifted 45 to the left. I promise you will be able to do this much more easily than me on paper. So let's have a quick look and just see that this did actually work. So we've got cos of x, and then our next one is cos of x plus 45. So you can see what's happened. The purple one has moved 45 degrees, and if I just kind of zoom in so that we've just got it between the 0 and 360, there it is, it's crossing at 45, going down here to 135, and then we've got your 225 and your 315. So let's have a look at their one and see if it makes any similarity to my one. I might actually draw what the cos graph normally looks like. The cos graph normally looks like this. Oh my god, these are just the worst graphs I've ever drawn. So you can kind of get a sense how every single coordinate has shifted 45 to the left. If in doubt, please have a look at this one and copy this one instead. I think you'll find this one a little bit better to copy. In fact, I'm just going to quickly change this so you can see really clearly all those places where it should have crossed. So the answer is the purple one between the 0 and the 360, and the green one I've put there just to try and make it a little bit easier to see. Okay, so let's have a look now at another example, one that should hopefully be easier to draw. Okay, so this time we want to sketch y equals minus tan of x. Well, it looks like our original one that we would have said, our f of x that we already know how to draw, is just tan x. And this time the minus is on the outside, so it's not going to be f of minus x, it's going to be minus f of x. So that's what we're trying to draw. We're trying to draw minus f of x. Minus f of x, if you remember, is a reflection, and it is a reflection in the x-axis. Now, when we have something that's outside, I always think about it as being like an up and down kind of thing, and people then say, oh, but the x-axis is left and right. But if you think about what the reflection looks like over the x-axis, it is still an up and down kind of movement. So I'm going to use this graph here at the top to help me sketch, okay? So remember, when you do this, let's start off with our axes, and we want to just be drawing it between 0 and 360. It's often easier actually just to start out drawing the regular graph and then to put the transformed graph on top of it. That is absolutely okay to do. So we know that the tan graph goes like this, where there's an asymptote at 90, and then we know there's this kind of shape here, that's 180, and then that's 270. I have drawn this very, very squished in here, but that's not a problem. And then we have this bit here as well, which finishes us off at 360. So this is our 90, 180, 270, and 360. That one is this graph that I have here. I'm now going to do the actual transformed graph in red, and we know all we need to do is just reflect this in the x-axis. So that means it's going to be coming down like this, and instead of it coming up towards this, it's going to come down like this and smooth there, and then down like this, and then it's going to be coming down from that asymptote and along. So I highly, highly recommend drawing the axes to begin with and drawing the original function. Then you can do whatever operation it is, whatever transformation that you need to perform on this one. So let's have a look, and you can use Desmos yourself if you want to check any of these answers as well. So I'm going to go and put tan x, and then the function that I wanted to do was minus tan x. So let's see if it's going to flip how we expected. It is going to flip how we expected. So we've got that kind of downward slope, and then this sort of downward shape here, and then a little bit like that. Let's see if that worked with ours. Yeah, we've got the downwards, that shape, and that, downwards, that shape, and that. Now, if you want to do this yourself, if you go into the settings, all you need to do is you make sure that you put it into degrees, this bit down here, and for the x-axis, you probably are just going to want to have it between, I don't know, 0 and 360, whatever it is that you're wanting to sketch. So if we just have a quick put, if I put mine between 0 and 360, and I put the step length as 90, then we get that tan graph that we've recognized before, and the red one is the one that we've just drawn. So you can definitely use these to help you to do your answers as well, okay? So you can now try exercise 9F and G, and you're really going to use, I would really recommend you, oh, not 9F, we've already done 9F, so it's actually just going to be exercise 9G, we've already done 9F. I would recommend you trying to do some of the mixed exercise questions as well, and using Desmos for this. I have picked out one question that I thought might be interesting for us to have a look at together, and then I'm going to stop the video there. Oh, no, it's this question here. So I'm going to do this one as well, and actually then I'm going to do one of this question. I forgot I had this extra one here. Sorry, guys. Right. So here, looks like the function we know how to draw is sine of x, but the function that we want is sine of x over 2. So that looks like we're changing the input. So we're going to be changing that to an x over 2. Now, if it's an x over 2, we know that's the same kind of thing as a half x, x over 2 and a half x. So we know it's going to be a left and right enlargement, or a stretch in the left and right direction. And the scale factor of this stretch, well, it's a half in front of the x, so the scale factor is going to be the reciprocal of that. It's going to be times 2. So that means that this whole thing that we've got here, the normal graph, is going to be stretched, so all of the x coordinates are being doubled. So if you just think about the sine graph, let's draw the sine graph, and then we'll see if we can add in, I think that's the way we're deciding that this is better, and we're doing it between 0 and 360. I'm going to draw the regular sine graph and see if that will help me to be able to draw the other one. So I'm going to do sine x here. Let's go to my pen. Regular sine graph looks like this. Well, it should do. It's a terrible drawing. And we're going to try and draw this stretched one now. So usually the peak is at 90. It crosses at 180. You have your 270 and your 360. So if we're stretching it, the peak is no longer going to be at 90. The peak is now going to be at 180. And if it crosses at 180, if you double that, because that's the scale factor, it's going to be 360. So actually, when you do this one, you get this really weird kind of shape. It just goes to 360. Now, I'm going to do that again because, as you've heard me say many times, I am terrible at drawing on this tablet, but I'm going to get better. just wanted the peak to be at the right place. So there's the 180 peak, and it crosses at 360. Hopefully we can see that the peak is meant to be at 180, and the idea is meant to be that both of these peaks here should match, and they should be at 1, because nothing's changed about how that peak should be. So let's have a quick look and see if this works here. So again, you can check your own answers like this. I'm going to go to sine x, and then I'm going to put in sine of x over 2. And there is that green one, it's just got that single bump. You can try and think about what would happen if we did the sine of 2x. So if we did the sine of 2x, we would actually be taking the graph and we would be compressing it. We would be doing a scale factor of 1/2. So instead of it crossing at 180, it would be crossing at 90. And instead of it crossing at 360, it would be crossing at 180. Try and imagine what that might look like before I hit the 2. Good, so the compression now means that it can go in twice. So you can fit 2 of those sine periods inside that overall sine that you've got there. So if I changed it to 3x, you'd get 3 of them that can fit in there, and 7 of them, you get 7 of them that can fit in there, etc. Okay. Last one to have a look at, and then you can try some questions. This one I just thought would show you some of the things that kind of combines this all together, okay? It says the diagram shows part of the graph of y equals f of x. It crosses the x-axis at A, which is 120 degrees, and it crosses B at P. It crosses the y-axis at 0q, and it has a maximum value of D as shown. Given that f of x equals the sine of x plus k, write down the value of these different things that we've got here. So f of x is the sine of x plus k. That means that you've added k onto the x1. So we know that this represents a translation, and because it's a plus k here, it's actually going to be a minus k, 0. And they've said that k is a positive number, which means it has actually moved to the left. Now, I like to draw on top of this what a normal sine graph looks like. So a normal sine graph should look like this, and we know that it normally crosses at 180, but it looks like it's now crossing at 120, so that must mean it's moved 60 to the left. So if it's moved 60 to the left, looks like we've got this. That should give me enough information to be able to do some of these questions that I've got here. So it says find the value of p. Well, normally it would be here at 360, but we've said it's just gone 60 to the left. So the value of p is 300. It then wants us to find out the coordinates of D. Well, the normal peak is at 90, but it's moved 60 to the left. So it's going to be 30, and the y, well, it hasn't been multiplied at all, so it's just going to be a 1. It's just going to be a 30 and a 1. It then wants the smallest value of k. Well, we've already got this one here. We've already said that k is going to be 60, but I just want to break down about why it's the smallest value of k. If you took the sine graph and you move it 60 to the left, it would look like this. But if you moved it 420 to the left, that's moving it 360. If you move a sine graph 360 to the left, it just lands on top of itself, and then you'd move another 60. So actually for this shift here, if it was a 360 degree shift, it wouldn't have shifted at all. I wonder if I can just show you that. So you've got sine of x minus 360. You see it doesn't shift at all. If I do the 420 shift, and if I do they had it as a plus, didn't they? You can see how the purple one and the green one are the same as each other, because there's a difference of 360 here, so they're kind of landing on top of each other. Okay, and that might mean for the last bit, the value of q. So the value of q, we need to try and find out where does it cross when x equals 0. Well, we now know that f of x is the sine of x plus 60. And so we want to find out what is the value of y, in other words, what is this when x equals 0. So we will do f of 0, which is the sine of 60. And when you put the sine of 60 in your calculator, you get root 3 over, you get root 3 over 2. So the value of q is root 3 over 2. Okay guys, so you should be able to have a go at doing exercise 9 Ex9G now, and that's us done with chapter 9.